Hey gang, so it is time for some trigonometry. So let's see what you remember from geometry and for those of you that had pre-cal. So on your handout, I kind of already did just some reminders. Equilateral triangles, all sides and angles are the same. And remember, you remember how to mark them. Here it is by sides, equilateral triangle, all side, let me say that again. All side length and angles are equal. And then over here is how you mark it. Acute triangle, all angles are acute, less than 9 degrees. Isosceles triangles, two sides and lengths corresponding angles are equal. Remember that. Right angle, triangle, one right angle, two acute. Scaling, all sides and length of angles are different. There's none that they're the same. Obtuse, one obtuse more than 90 degree angle. And that's just kind of the basics. We are primarily going to deal with right angle triangles, but we are going to have a variety of those in there. So that's just kind of a reminder there. All right, so let's see what you remember about your trig ratios. Remember you had 3, and you also had something that you probably remember, SOA, CA, TOA. Okay, so remember that is where we say sine theta, we say cosine theta, and we say tangent of angle theta. Now, remember in your calculator, when you are working with trig, you want to be sure to go to mode and you want to turn it to degrees, because everything we do is going to be a 30 degree angle, a 40 degree angle, things like that. So you want to be sure that you are on degrees on that. All right, sine. What was the rule for sine when you have a right triangle? And I have theta down here. SOA. The sine of this angle theta is opposite over hypotenuse. So we are going to write opposite over hypotenuse, or O over H. For cosine of theta of this angle right here, it's the CA. It is the adjacent angle. Adjacent is the one that touches theta, so it's the adjacent over the hypotenuse, or A over H. SOH, CAH, and tangent of theta, we are going to take the opposite over the adjacent. Opposite over adjacent. Now, when I learned this back in the day, I learned it, maybe it was because I was from the country, I don't know. I learned it as some old horse caught another horse taking oats away. And I always do that whenever I'm doing it. So I'm trying to train my brain to do SOA, CA, TOA, but you know, I sometimes will slip and you might hear me say, some old horse caught another horse taking oats away. All right, so here we go. So example 1, let's see if you remember this. This is exactly what you were doing when you did geometry. All right, so in right triangle ABC, cosine of angle A equals 3 over 4. Find sine of A and tangent of A. So I've drawn it here. Here is triangle ABC, A, B, C. And across from the B right here, this is beta, this is alpha, and here's my right triangle. For right triangle trigonometry, always remember it has to be a right angle somewhere. So here's what it tells me, cosine of A. So cosine of A, well here's A, is 3 over 4. Well remember cosine is CAH. So this is adjacent over hypotenuse. So from this angle right here, the adjacent is 3. So adjacent is 3. And the hypotenuse is 4. So the hypotenuse is 4. So we don't know that angle or that measurement right there. So I'm going to have to figure that out in order to do sine of A and tangent of A. Well, let's see. Sine of A would be opposite, which would be x over hypotenuse, which is 4. Tangent would be opposite, which is x, over adjacent, which is 3. But I can't leave it like that. They want to know what is x. Well, what do you know about a right triangle? Oh yeah, isn't there that like theorem thingy that we know? Something about a squared plus b squared equals c squared? Okay, 3, 4, what's that other angle over here? Well, let's see. I'm going to go ahead and write it. 3 squared plus x squared equals 4 squared. So that's 9 plus x squared equals 16. X squared equals 7, because I'm going to subtract 9 from both sides. And then remember, to find the square root, I'm going to take the square root of both sides. And so x equals the square root of 7. Now, I'm not going to put a value there. I'm going to keep it as the square root of 7. I'm going to substitute this in. So this is going to be the square root of 7 over 4. And this is the square root of 7 over 3. These are going to be approximations. So we're going to plug that into our calculator and we're going to figure it out. Now, I've already done it, so I'm going to go ahead and just give you my answers here. I got 0.6, and I'm doing 3 sig figs, 0.661. And on this one, I got 0.882. If you got something different, try it again. If you still get that same thing, I probably got it wrong whenever I did it, so I'm going to trust that I think I got it right. All right, and so that was our example 1. Let's turn the page. Hopefully you guys picked these pages up at the drive-thru the other day that Miss Lynch did. Nope, not Lynch, Lentz. All right, find the missing side. Any problem related to finding a missing side of a, and this is brutal right here, very crucial. I may have picked it of a right triangle. It is so important that you notice that that says right triangle. Remember, right triangle trigonometry. Okay. Any problem related to this, we're going to have 3 steps that we use to solve these. Okay. The first one, we're going to label the triangle and identify what trig ratio are we doing. So let's say label. I'm just going to cheat and I'm going to say triangle. And identify trig ratios. Identify which trig ratio you're going to use. And you might put SOA, CA, TOA. I didn't get that TOA. Okay. Then we need to substitute the values into the correct ratio. So we're going to substitute. The values into the ratio, into trig ratio. Let's put. Then we're going to do what we just did a while ago. We're going to rearrange it and solve. All right, so we've kind of got our rule here that we're going to follow. All right, so example 2. I'm going to leave that there in case you're still writing. Triangle ABC is a right-angled triangle. Very important that you see that. In which angle C is 51 degrees. So I've drawn it right here. Angle C is 51 degrees. Angle B is 90, and I've drawn the 90. And the length of AC, which is our hypotenuse, is 11. Find the length of AB. And we're going to put an X right there. And so we want to know X. So I have to look at it and I go, okay, I've labeled it. Now I need to identify, is it SOA, CA, or TOA? So I've got the angle here. I am trying to find the opposite side. This over here is the hypotenuse. So I'm using opposite and hypotenuse. So if I'm using opposite over hypotenuse, which trig function is that? Well, that would be sine. Sine theta is opposite over hypotenuse. Okay, so here's what I know. I know that the sine of 51 degrees equals the opposite, which in this particular instance is x, over hypotenuse, which is 11. Okay, I'm just going to use some simple algebra, and I'm going to solve this. This is dividing. To get the 11 out from underneath here, I'm going to multiply both sides by 11. and that would cancel those out. And so I'm going to write it. You don't have to, but I want to write it. 11 sine of 51 equals x. I'm going to solve this right here. So I'm going to say 11 sine 51, and I'm going to go, okay, I do remember that I am in degrees because I'm doing 51 degrees, and it's 8.548. 3 sig figs is 8.55. So x equals 8.55, and it's centimeters, and there's my answer. All right, example 3 down here is a little bit more involved. All right, so here we go. JML and KML are right-angled triangles. Again, key word, right-angled triangles. With angle JML is 90, and you can kind of look on here. KLKM is 90. If JM is 10 and angle KJM is 63 degrees, find the length of the sides KM, JK, ML, and JL. So this is all together, and sometimes my brain can't quite comprehend what all is going on. But I know there's this great big triangle, JML, and it's got a right angle in M. So I'm going to break this apart, and I'm going to redraw this JML. This is my right angle, and I know that this angle down here is 63 degrees. Okay. All right, that's the one I know. Now I'm going to draw the other one. So the other one, can you see it right here? And you've got your right, it's JKM. Now this is going to sound funny, but I'm going to draw it like this. And the right angle is at K. And then M is up here at the top. All right, hold on one second. Okay, yeah, totally lost track of where I was. So I'm just going to do it again. So I'm going to take the little one and put it here. K is my 9-degree angle. J is my 63, and M is the one at the top. So this is M, and this is J down here. J is the one that I know is 63 degrees. And across from the 90 degree, I know that JM is 10. So I know that JM is 10, JM is 10. So that's what I know on my two triangles, if I like break them apart so that I can even see. Now, what was it they wanted to know? There's a whole lot of things they want to know. They want to know the length of KM. So I'm going to come up here and I'm going to say we want the length of KM. So KM is this side right here, right? So I need to figure out what that side is. Well, I know an angle and I know the side. So which angle do I know? Well, over here, KM is right here. I'm going to call KMX. I want to know the side opposite the 63. That's opposite. And I know the hypotenuse. So here we go. So I'm going to say sine theta is opposite over hypotenuse, right? That'll be the sine. So sine of 63 equals the opposite side, which is x, over the hypotenuse, which is 10. Okay, so I'm using this one. I'm going to set that up. I'm going to solve this. Remember that whenever you have the number on the bottom, you're dividing. So if I multiply both sides by 10, those cancel out. I'm going to do the math right here, and x is going to be approximate 10 times the sine of 63. When I put that in my calculator, I'm going to get 8.9100. I'm just going to put that there for now. Or 8.91. So that means KM over here is approximately 8.91 km. Now I don't have km anywhere else. I'm going to write that there. Okay, so km, I'm going to actually mark that off. The next one is JK. I feel a sneeze coming on. Oh, excuse me. Oh, okay. JK. Okay, so I'm going to call this right here, let's call this Y. Well, let's see. I know you may be thinking, oh, could I do a squared b squared equals c squared? You could, but let's not. Let's use trig. So I know 63, so I'm trying to find the side adjacent to it, and I know the hypotenuse. I also know the side opposite, but since I found this one, I'd rather use the numbers that were given. So if I'm doing that, that's cosine theta is adjacent over hypotenuse. So cosine of 63 equals adjacent, which is y, over the hypotenuse, which is 10. Well, remember, to get rid of it, we're going to multiply both sides by 10. Those are going to cancel out. And I'm going to get that y is approximate. I'm going to give you a second to put that in your calculator. I got 4.5399. I'm going to put 3 sig figs on that and do y is approximately 4.54. 4.54. Is it centimeters? Did I see centimeters somewhere on this? Centimeters. So I would need to put centimeters on both of these. And you might be going, oh, Miss Dean, on the x you didn't put 3 sig figs. I did not. So we know we didn't. So if we were doing a test, we would go back and fix that. Okay, so I'm going to mark JK off. I've done that. All right, next thing is ML. So ML is this side over here. So I'm going to call that X. Well, let's see. I'm going to see if you can set that up. All right. This one, that's not the hypotenuse. This is the opposite side. That's the opposite. And this is the adjacent. So for ML, I'm going to use tangent of theta is opposite over adjacent. So tangent of 63 is the opposite over the adjacent. So I'm going to multiply both sides by 10. Oh, I grabbed the black instead of here. Those will cancel out. 10 times tangent of theta is the x side. All right, I got 19.6 centimeters. See if you get that. All right, and I'm going to mark off ML. And then the last one I have is JL. All right. JL is this the hypotenuse, right? So I'm going to call that y. I want to know this hypotenuse. And remember, I know we could use the x, but we just found that one, so let's not use it. Let's use the one that we were given. So of 63 degrees, this is the adjacent, and this is the hypotenuse. So which one involves adjacent and hypotenuse is our cosine. Cosine theta is adjacent over hypotenuse. So cosine of 63 is adjacent over, oh, I did it backwards, didn't I? Adjacent is 10. Man, adjacent is 10. Over the hypotenuse. Okay, so algebraically I need to solve this. So I'm going to think about it like this. I'm going to multiply both sides by y, and that would make these cancel out. To get rid of cosine and move it to the other side, I would divide both sides by cosine 63. So here's what I would end up having. Y equals 10 on top over cosine 63. All right, so y is approximately, here we go, 10 divided by cosine of 63. I got 22.026, or 22.0 is what I would call that, centimeters. I'm just going to leave it there for now. All right, there we go. On to example number 4. Hopefully you're remembering the trig and you're like, oh yeah, I forgot. This is fun stuff, man. I enjoy the trig part of this. All right, in the triangle below, angle F is 90 degrees. GF is 400. GF, that G got cut out. GF is 400. GH is 1330. Find the size of angle GHF. So we are trying to find this angle right here. I'm going to call that theta. So I'm going to let you think about what you know. You know the opposite side, and you know the hypotenuse, right? So you know the opposite side, and you know the hypotenuse. Sometimes it's helpful to kind of label those. This would be the adjacent side. So which trig function involves the opposite and the hypotenuse? Well, SOA. So sine of theta equals the opposite over the hypotenuse. So sine of theta would be the opposite over the hypotenuse. There we go. Now, how do you find it? Because you can't put sine theta into your calculator. So whenever you want to find the angle, we do the inverse. So think of it like this. It's sine with a -1. That's like the inverse. That's how you find the angle. So sine inverse of 400 divided by 1330. What is that? So I'm going to take my calculator and turn it on, clear it out. So inverse sine is right here. See that sine to the -1? Inverse sine. And I'm going to do alpha y equals, and I'm going to put in 400 on top. Oh, 400 on top. And 1330 on bottom. Move to the right and close it. Always be sure you close it. Alright, so there it is. Now remember, we always want to make sure we're in degrees. This is 17.5027. Remember, what are you finding? You're finding the measure of angle theta right there. So you just figured out that theta is approximately 17.5 degrees. You're finding the angle degree. Okay, let's try number 5. Find the area of the triangle ABC. Well, when you look at this, first off, they don't really tell me whether or not this is a right triangle, so I cannot assume that it is. But I do know the area of a triangle is 1/2 base times height. So I'm going to draw a right angle down, and that's my right angle. Could I figure out, I'll call this ABC, we'll call that point D. Could I figure out the length of BD? Absolutely. I don't know this one. I can't say that this is 11 because I'm only going from here to here. So I have to kind of think about it as, can I use that 11 on here? And I really can't. But I could call this right here, I'll just call this X. And could I figure out the length of X? Well, let's see. 35 I know the opposite, and wouldn't 9 be the hypotenuse? So could I say that the sine of 35 degrees equals the opposite, which is X, over the hypotenuse, which is 9? Alright, so let's say that X is approximately 9 times sine of 35 degrees. Alright, so 9 times the sine of 35 degrees .16. Okay, so now I know this right here is 5.16. 5.16. Underline it. Alright, so the area of a triangle is 1/2 the base, which is 11, times the height, which is 5.16, right? Alright, so area equals 1/2 the base times the height, which is 5.16. Alright, here we go. I'm going to clear that out. 0.5 times 11 times 5.16. Oh, I didn't get it on there. 0.5 times 11 times 5.16. I got 28.38 for the area equals, I'm going to say 28.4, and it was centimeters squared. Okay, now that, it was a little bit of work there to do it, but it would work as well. Now, I want to give you a formula that works when you don't have a right triangle. If you're just given a triangle and you want to find the area, you have a formula. The area equals 1/2 side A times side B times the sine of angle C. All right, and we are going to make that big and bold because we are going to use this a lot. I want it to stand out when I have to go to my notes and try and find it. I want to remember that. You will actually, because we're going to use it so much, you will memorize this one. So I want to use this one on this. All right, so here we go. Area equals 1/2. We need to find A. Well, here's theta. Across from this would be A and B. A is going to be right, I said across from, I shouldn't have said that. This is going to be A. The other angle, it's, think about it like the angles in the middle, side, angle, side. They have to be touching, so this is B, and this is the angle that we're going to use. So we're going to say 9 times 11 times the sine of 35 degrees. And we're going to plug that in. There we go. I'm going to plug it all in. 0.5 times 9 times 11 times the sine of 35. Oh, look at that. It is 28.392. Or area is approximately 28.9 rounds the 3 to a 4 centimeters squared. Same answer. There it is. A little bit less work, I think, to do this formula, but do you have to do that formula? Absolutely not. IB would love. It doesn't care which way you do it. All right, so that concludes that. We're going to do the sine rule next, but I wanted to get that part of the video done.